Hello, everyone. Today we'll talk about 10 practices to effectively leverage DevOps. First, I will cover the agenda for this talk, do a little intro about myself, and then we cover definition of DevOps, our thought, high-level overview of DevOps, and then which we'll talk about the different aspects of DevOps, and then the main part of this presentation, effectively leveraging DevOps. Excuse me. Spend most of my time on that. And then we'll talk about common barriers company face. And then we'll look at some metrics from the industry and also metrics within our organization from some of the projects we've done. And then at the end, there'll be time for questions. So there are different definitions of DevOps, and here's our take on it. It's a collaborative intersection of business, product development, quality engineering, IT operations, and end users. It consists of procedure, process, tools that improve stability, consistency, configurability, communication within your software development lifecycle or your product development, operation, adaptability, and time to market. So if you look here, there is no reference to tools. The focus is basically on people. It's people from the business side, product development, which is basically your software developers, your infrastructure engineers, QE people, as mentioned below, and also your release management team, right? And also your monitoring team. It's coming together of all these teams together for a common objective, a common vision to deliver software. So here's a high-level overview of DevOps. And as you can see, DevOps is not a single person. It's not a role. It's coming together of different groups together, like I've mentioned before, and you're going to hear me repeat this throughout this talk. It's coming together of different groups to deliver software product and with a common vision. Now, what does that entail? You're going to have your planning. It's backlog grooming, it's sprint planning, and be it any part of that software development, be it QE, be it infrastructure, be it the application automation people who do the CI/CD, everybody builds out a backlog. They plan the sprint, and that's one of the ways to be effective when you're delivering software. You're going to build, which is your CI/CD, your configuration management, creating artifacts, things like that, and automation testing, which is it can be your unit test, it can be your regression test, it can be your performance test, it can be some smoke tests you're performing in UAT or even in production. It's managing your release pipeline, how that's done, how release management come into play, how are you managing your artifacts, and then finally, the last two are your operations, where you're managing your infrastructure, your configuration of the resources where your artifacts are deployed, you're setting up those health checks, and then monitoring, where once you have sent it out to the world, how are you monitoring it, or usage? How are you monitoring, like if there are any failures? How are you getting your user feedback? Managing your support tickets. Okay, which then brings us to our main topic. Here, the very first thing you should think about when you are starting out this journey is that it is a cultural change. And when I say that is, people are used to within an organization to do things in a certain way, right? So you are been doing software development for months, years, many years a certain way. So it is changing your thought process. And a few things here when you're thinking about culture is that you should have a leader as a champion within the organization. It can be a leader at a director or C-level who truly believes that, yes, this is going to bring us benefit. So have to have the champion. And also as an organization, you should be willing to embrace a new way of doing things. Working, it's about working, thinking, and behaving too. Again, it's not about tools, it's about collaboration of all the teams coming together with a common vision. Repeating myself again, but that's the key. It's bringing these different teams together to be successful and to deliver a product. Everyone works on a common vision. Everybody thinks they are one big team. It's about building those bridges between your dev teams, your product team. And I say product team, it could be the product owners, your business, operations, right? And support. It's about empowering the teams. It's the team would be responsible for committing to what they're going to be delivering, and they are responsible for sizing it out and then delivering, going back to that backlog grooming part of it, where you're doing your sprint planning, your user stories, and things like that. And when you start making these changes, you are going to see a little bit of a little bit of pain, and you should see it. And if you are not feeling that destructive pain, then probably you're not doing something right. And always when you start off first, it is going to be a disruptive. Got to be careful here that when you're making these changes, you don't bring everything to a standstill. So there's that balance. Yeah, you got to make the change, but also make sure that you are not telling the business that while we are making this change, we are not going to be doing product releases, right? That balance will never work. Next thing is understanding your requirements. So here, it is not only just your business requirements, it is also understanding your technical requirements. And what do I mean by that? When you are developing a product, you're going to have features. Now you need to understand what that feature is truly delivering as a benefit to the product. And when that happens, when the product owner is talking about the feature and then the dev teams are breaking it down into user stories, should also have your CI/CD people involved. You should have your infrastructure automation people involved, your QE people involved too, so that you understand what you're delivering and what's the expectation for the backing resource. Do you need some kind of messaging system? Do you need a VM? What kind of database do you need? Do you need a SQL? Do you need a NoSQL? What kind of the amount of data which is going to be hosted in this database, right? Or persisted in this database, things like that. It is good to have these different groups or the leads from these different groups in this conversation. That way you understand how you can deliver that feature and what are the backing stories which are required to be created. Also, you understand your dependencies too. So I was involved in a couple of large projects where there are like 300, 400 developers. And we used to do planning every 3 months for the next set of features, which would be released throughout that 3-month window. And we used to get in a room now, of course, people are virtual, but yeah, we used to get in a room for 3 days and plan. And everybody is there. You have your product owners, you have your developers, QE, the DevOps team, the infrastructure automation team, and in this case, it was in the cloud, so the cloud ops team, the the support team, everybody was there. So you sat in that room for 3 days, planned, you understood your dependencies, and you planned out your sprint that way, so that you know that when you're developing, let's say you are going to deliver feature A in sprint 3, that means your infrastructure has to be ready in sprint 1. Your automation and things like that needs to be done in sprint 2. So that's helpful to understand those dependencies. So understanding those requirements is for all the teams, coming together, understanding the dependencies, building out their user stories or features and things like that. And the advantage there is, yeah, when you understand your requirements, you can ideate your features and your capabilities, like I mentioned before, which will help determine what tools or the backing resources you would need to deploy that particular piece of application. Version control. In today's world, everybody should be doing this. If you are in an organization where you still have code residing in someone's PC or laptop to be doing deployments, then that's something to be thought about, and you should be worried. You should be using some kind of a version control. Today, a lot of organizations are using Git to do this, and it's fine to use a distributed version control or a centralized, but then you've got to think about a version control tool which you should be using. And today there are a lot of tools out there to help you out with this. And as you're thinking about a version control, you should have a clear process on how you're going to manage your merges, how you're going to manage your pull requests or PRs. What are pull requests? These are code review requests which are created from a feature development branch into your, it can be your trunk if you're doing trunk-based development, and I'll talk about it in a minute. Or if you are doing like a dev branch, perfectly fine. You just need to understand what the needs are within your organization, what fits your development process and your cadence. Your branches should be short-lived. What do I mean by that? Is that you should have branches which don't live for more than a sprint. Ideally, it shouldn't live more than a user story. You're creating your feature branches which relate to a feature user story, and it should not live for more than that. That way, your changes are short-lived and you don't have too many merge conflicts when you're ready to complete that branch through a PR. Think about your branching and merging strategy too. I can do like a 2-hour talk just on this. There are various ways you can do your branching and merging strategies. There's trunk-based development, which I just mentioned before. There is, you can do release-based, and you can do release-based with feature branches. But yeah, there are different ways you can do your branching and merging strategy, and there are a lot of references as to how you can do. One of the ones is Git flow. The other way of doing your development is trunk-based, where you have a single branch, which is your single source of truth. When I say a single branch, that's your main or your master or trunk. Everybody works off of that. They create feature branches off of that. They do their development on that. And then when they are ready, they they create a pull request for their peers to review or leads to review the code before it gets merged uh, into your trunk. The next one is continuous integration and continuous delivery. In continuous integration, uh, which is the first part of your CI/CD process, is where you are building out your artifact. You are building out a pipeline. You can use whatever the build automation tool is, where the code is checked out, it's built. And as part of the build process, you are going to be running a couple of steps. One of it is you are going to be running your unit test, and the unit test is going to generate a couple of reports if you're using additional tools to generate your unit test results, which basically says whether how much of your unit test is passed, whether it's 100%, 80%, 90% passed, and you can generate that report. Now you can set up your pipeline to say, to fail if 100% of your unit tests don't pass. So at that point, it doesn't go any further. The other thing is you can have code coverage. And what I mean by this is that based on your unit test, what percentage of your code is covered by your unit test? Is it 30%, 60%, 80%, whatever it is? And you can use those metrics to decide if you want to take your build further or not. If you think that 60% of the code is not the right threshold to move your code forward, you can just fail the build right there. Or the other way, and I've done this in other projects, is where you start off with a baseline, where you start off with 40% code coverage. But then what you are setting up as part of the build is that every build from there on has to be equal to or better than that 40% of code coverage. So you're constantly improving as you are adding more and more code. So that's the other thing you can include as part of your CI. The next thing you can include is security scans. And in this case, you would have static code analysis. What this is, you have a lot of third-party tools where you can upload your code and they run through some scans on your code to look for vulnerabilities. Are you using the right package version? If you're using a third party, are there any security vulnerabilities with those third party tools? And are there any issues with your code itself, which is going to cause a security issue? So it runs these and then it reports back. So you can include that as part of your pipeline. So that's the CI part. Now coming to CD, CD can be two. It can be continuous delivery or continuous deployment. So what's the difference between these two? Continuous delivery is where you are building out a pipeline which has some kind of approval gate in it. So when you build out your stages which equate to environment, in the lower environment, probably you don't have any approval gates. But then if you go to higher environments, you might have some approval gates. And what I mean by that is that you can have someone come in and approve it before it can be deployed to an A environment. Like for instance, in a lower environment, let's say the integration environment, the QE team is not ready to take in. So then you build out your pipeline, and as part of the pipeline, you have that approval gate built in for a QE lead to come in and approve it to be deployed to that integration environment. And as you go higher, let's say pre-prod or prod or staging, you can have release management come in and approve it before it can be deployed to those higher environments. So that's your continuous delivery. Now, continuous deployment does not have any approval gates. So it's an automated process where you can have a set of unit tests run, and then if those tests pass, then you not unit tests, your your QE automation tests. And if those tests pass, then you can deploy to that environment. Now you can have a larger set of QE automation tests run in your lower environments, and a small set, which is like a smoke test, run in your production environment. Now, both continuous delivery and continuous deployment are both valid options. You just need to understand from your organization or even within your product development team what option fits you, and then pick that and go with that. The continuous deployment is a more mature model where you would have a more mature pipeline and mature QE automation. And that might take a little bit of time. So you can start with your continuous delivery and then move on to the continuous deployment. What are the benefits with this is that you are doing frequent deployments. When you have a CI/CD, you are doing frequent deployments, and it can be multiple times in a day in your lower environments. And then as you go higher, if you're mature enough, you can do multiple deployments even in your higher environments. It sets the stage for you to get to that maturity. Agile software development. Think Agile here. You should have shorter release cycles, and also which helps in showing value quicker. And since you are deploying more frequently, you are going to get your feedback also quicker. And what does that do for the team? It helps since you're getting that feedback or the data point, it helps you to adjust and pivot, right? For instance, you might be building out a feature for the business, but then something changed in the business and you need to make a change and build out that feature differently. So when you're agile, you're able to do that. Whereas from a traditional waterfall, you go off, you are given the requirements, you go off and you build out the whole product, and nothing is seen till what, 6, 8, 9 months, a year and a half. When you think agile, you are doing shorter releases, and also, or your release cadence is shorter, and you get that feedback quicker. The other thing here, and which mentioned is, as part of this, you should have all of your teams who are delivering the software and also the backing resources building out their user stories, like I mentioned earlier, which helps for visibility too. And if you were on Brad's talk this morning, he talked about his project where they have user stories even for the DevOps team or for the infrastructure team. So it helps you to build that out. And visibility too, as to where they are, you understand your dependencies, things like that. Test automation. To start off, you may not have test automation as part of your CD pipeline, but the goal should be to get to that point. And how do you get there? Is one of the things you can start off doing is you can provide those interim builds to QE so that they can start building out those test automation, the test automation suite. Once you are at a certain point where you have a decent amount of test automation, you can then start to include that as part of your CD. And like I mentioned earlier, you can have these test automation, a larger suite running in your lower environments like an integration or a QE environment. And as you go to higher environments, you can um, you can have a smoke test run or a smaller suite of those test automation run, even in production. There is a talk later today by Dan and Jake who talk about using deployment slots in Azure to do test automation. So if you can check that out, pretty interesting how they're doing it on their project. The other thing is that if you are doing your test automation as part of your CD, you are going to, it's a repeatable process and you are going to be getting consistent results. Also, if you are doing the test automation, one thing which it'll help is to make sure that your environments are consistent, because you are running these test automation with the thought that this is how the system is going to be used in production. So running these test automation would definitely help in two things: having a consistent environment. And if you don't, and you're seeing different results between your different environments, then you might want to go back and revisit how your environments are provisioned and configured. And if your environments are configured correctly, test over test, you are going to get consistent results. Security. I touched on this a little bit when I was talking about CI, and where I talked about static and dynamic code analysis. Static analysis I've mentioned enough. Let's talk about dynamic code analysis. Now, dynamic code analysis is done post-deployment. So you deploy to an environment, and then there are third-party tools which run against this environment. It goes through running through certain use cases or certain your feature path, right? It exercises your application. And as part of that, it's going to look at the same things like your vulnerabilities. And this is like post-deployment. And when they're exercising a particular feature within the tool, it's going to report if there are any vulnerabilities, and these are reported back. And these can be built into your pipelines, right? And yeah, and today's world, if you're doing Docker and Docker containers, you want to scan your Docker those Docker containers, your Docker builds, and look if there are any vulnerabilities in there before you deploy it out into production. The other thing which security helps is that you can set up your systems in a way that if they are not to be accessed directly, then you can set up your VNets and your subnets and your security groups in that way. Let's say you have an API which should not be exposed out to the world. So you then set up your app gateways and your firewalls and things like that, so that it's not accessible outside the world, and it's just accessible to the let's say your front-end application. It's going to use that API, and that's the only thing which should access it. So security helps with setting up those kind of designs. The other thing with security helps is immutable resources. And what I mean by that is that, let's say you would need resources to run tests. So you can spin up those resources, and when they are done, you just tear it down. And what that helps is that you don't have resources sitting out there, which can be vulnerable to attacks. So you use a resource, you tear it down, and then you spin it up when you need it. And those can be done with, and if you want to do that effectively, You can do that using IAC, and which brings us to the next topic, infrastructure as code, or IAC. Now, if you are doing IAC, the advantages of that is that you are going to have your code reside side by side. Your infrastructure code resides side by side with your application code. What does that do? It helps versioning, version control. Going back to that, it helps versioning, it helps traceability, and also it helps with repeatability. And the most important thing, you are going to have consistent environments across the board. So if you have, let's say, a messaging a resource which is provisioned, it is going to have the same configuration, be it in QA, be it in UAT, or in production. And since it's coded out, it is repeatable, it's less prone to errors, and you have it versioned side by side with your code. So you have that traceability of knowing what configuration or what resources are provisioned in which environment. Which brings us to the next topic of configuration management. Configuration management helps you to manage your provision resources. So you have a centralized place where you can see in each of the environments what resources are provisioned, and also it keeps track of those configuration. It keeps track of configuration drift, and by that I mean is if you have someone go in, let's say in a lower environment, and change a configuration for simple example of VM. They wanted more memory, they went in and they changed it for the VM. Now your configuration manager is going to keep track of it, and it can send out alerts that in an environment for an XYZ VM, someone went in and changed the memory. You can get an alert. You can also set it up to go in and automatically revert those configurations. So someone went in and said, oh, I want 32 gigs of memory from 16. It can go back in and revert it back to 16 gigs. So it keeps track of that. And they are tools to manage your configuration for your environment. Finally, continuous monitoring. You want to be thinking about monitoring and on mature DevOps practices. You would be monitoring both your system resources and also your application itself. You want to be monitoring how your system resources are doing, and also how are your application generating any errors. You want to be setting up thresholds and also setting up alerts. So when I say alerts, let's say that you have an application running in a service in the cloud, and your memory is starting to max out. You want to send out those alerts, or suddenly your application is throwing a lot of 500 errors. You want to set up those alerts. You also want to be careful as to how you set these up, because you don't want a lot of noise. That is like the same alert being repeated over and over again. And that comes with maturity. So you want to make sure that the same alert is not sent out every minute, right? So that comes with maturity and then with learning and ideation. The other thing is thresholds, and tied to that is dynamic scaling. Going back to the same example, let's say you have the service running, and let's say you when it reaches 70% of memory, you want to spin up another instance of it, right? And that's what is dynamic scaling. So you reach a certain threshold, you want to spin it up. And then you also want to spin it down when things start to settle down a little bit. Um, and let's say your memory falls back to 40% and for 10 or 30 minutes. And at that point, you want to scale it down by that additional resources you added. The other thing is you also can get feedback on your application usage and feature usage. What I mean by that is you've deployed a new feature to your application and you want to see if people are using it. So you can get that kind of feedback too when you set up monitoring. And also you get telemetry around it, as in uh, who is using the application, what demographics, if this is like a global app, where it's being used, time of the day it's being used, certain features like I mentioned earlier, things like that. And also based on the time of the day, you can decide, let's say between noon and 2 every day, there is a spike. So based on that, you can decide, that's the time maybe I want to scale so that I don't see any performance degradation. So things like that you can get when you do continuous monitoring. Common barriers companies face when they start to think about their DevOps journey. And, one of them is the legacy change management process. It's documentation, it's document intensive. You have a lot of documentation and a lot of approvals which you have to do before you can push something out, even to a higher environment, let alone production, right? Think about areas where you can automate that. For instance, let's say, is it enough as part of your pipeline, you have someone from, let's say, QE group come in and approve it, right? And that's self-documented. Or you can have your POs come into the pipeline and approve it. Now, as part of your pipeline, you have your approvals also built in. So think about that, and that can reduce some of that approval process or that paperwork which you have to do. Outdated testing practices. A lot of your testing is just manual testing. You deploy to an environment and then you have a swarm of QA people coming in and testing them. Not saying do away with manual testing, but see where are areas of opportunity to automate and create those automation tests. The advantage, again, like I mentioned before, is that it becomes a repeatable process. Governance as an afterthought. Here, you want to think about a couple of things. Set up those governance process as to how a person can request a resource. Let it be, and this is not just applicable to the cloud, it can be applicable even to your data centers, or if you're still on-prem, perfectly fine. Think about how they need to go request new resources, right? What the process is. Also, how do you get approval from your security team if you're going to start using a new feature in the cloud? How does that process work? So think about that. How do people get access to these resources? What level of access do they have? How do they request those access? So think about those things as part of your governance. You mentioned earlier, gotta have somebody who will champion this process for you and say, yes, this is the direction we're going to go, and who are setting almost the mandate for it. And that would definitely help moving forward with your DevOps journey. Inconsistent the next one is inconsistent environments, right? If you are provisioning your resources manually, it's bound to happen. People go in and a request comes up, they make a change in one environment and it's not documented. They forget, and as you're going on the day of production, you see weird results in production. Someone just forgot and did not account for that change for production. And people are swarming on production day trying to figure out what went wrong where and trying to figure out what change needs to be made. IC definitely helps with that because it's code, and you can build pipelines for it. And that way you are building out your pipeline most of the time all the way to production. You may not exercise it or execute it in production, but you have it built out. The last thing is, yeah, Agile definitely helps. Like I mentioned earlier, it helps in a shorter release cadence. You get that quicker feedback, and by getting that feedback, you know whether you need to continue on the path or make adjustments or pivot. Here's some of the industry metrics on a mature DevOps, where people have done mature DevOps. And here, when they say 440 times faster lead time, it is basically they've improved from a feature inception, and I mean feature inception, someone thinking about it, to getting it to production. So the speed to get that. One thing I'd like to stress here is that it also improved employee retention by 2.2 times, right? Also, a couple of other things. Since it's a repeatable process, 24x times you can recover faster, right? You can 46 times faster, or you can do more frequent deployments. So these are some of the industry metrics, and this is some of our own metrics from our projects, which we have done, and some of the case studies. So it reduced the regression testing on some of our projects, right, by 98%. It increased our releases to production 300 times. It increased the release capacity, so the capacity for people, because it's automated, and these two are kind of tied to each other, right? You have the capacity, so you're able to do more frequent deployments, fewer regression defects, right? Less downtime, things like that. So these are some of our real world metrics. I hope this talk was helpful.